Okay, so this is the second method of the same question, right? So this time we are gonna use, this is the second method, we're gonna use the current for in the current formula in the basically capacitance formula, right? So I is equals to I initial E minus T by RC, right? And you know, as we know, it's only is used in capacitors, right? Okay, so now basically we can calculate the current when the basically LED just switches off, right? So that current is basically, which is this current, right? This current is basically I is equals to V by R, which is basically 1.4 by 340, right? Which gives you 4.12 times 10 raised to power minus 3 amps, right? Or I have rounded off, but the value was 1.11764, and then it's 10 raised to power minus 3, right? Okay, so we got this value when the LED is basically gonna shut off, right? So now we're gonna use the potential divider. As we know, the potential divider formula is V1 is equals to R1 by R1 plus R2 plus, times V voltage of the source, right? So this one is voltage, right, of any resistor, right? And this is voltage of source, and this is resistance, resistance of LED, right? And basically this one is resistance of basically what was it called, resistor, the R, right? So now we are gonna basically put in the values. So V1 is our V initial, right? Because we are finding the initial LED, basically initial LED voltage, right? So that is our V initial. We need to find V initial for the LED. We know that R1 is basically resistance of the LED, which is 340 by total resistance, right? R1 plus R2 is total resistance of LED and resistor, so it's 1200. You can add them up. 860 plus 640, this is actually 860 plus 340, you get this at 1200, and then you multiply it by basically the voltage of the source. Basically it's 12 volts, right? Because the capacitor has 12 volts, right? So we get V initial as basically 3.4 volt. Now we will convert it into current, right, for current initial. So current initial is equals to V by R. Now we have this V, which is the initial V for the LED, which is 3.4, and we have the resistance of the LED, which is basically 340. So we get this as 1 times 10 raised to power minus 2 amps, right? We get this resistance, current, right? So now we're gonna input the value. We have our I, which is 4.11764 and dot dot dot, and then times 10 raised to power minus 3. Then we have equal to the initial, which is 1 times 10 raised to power minus 2, E minus, we have time, which is 10 minutes, which is 10 times 60 to convert it into seconds, right? And then we have R is the total resistance. Remember that R is basically total resistance, right? So basically the total resistance is 12,000, and we have to find the capacitance. So once you calculated this through your calculator, you will get your answer as 0.56 F. Now you have to choose between 0.54 F and 0.58 F, right? Which one is the best one to be chosen? Now we know the time is, which basically must not be less than 10, right? It must not be less than 10. No, it should be like close to 10 or maybe greater than 10, not less than 10, right? Okay, so this will most probably provide us with less than 10 minutes. You know, it will basically be less than 10 minutes. The LED will be shining and then it will close up. So we can't use this one. We have to use this one because we need either close to 10 or greater than 10, right? So this will be our final answer, right? So we can mark this as answer, right?